In this video, we'll be doing more problems where we'll apply the rules of probability, the AND rule, the OR rule, and the at least one rule. So the two events are rolling a 3 and rolling a red number on a die in which the even numbers are red and the odd numbers are black. So the red numbers are 2, 4, and 6, and the black numbers are 1, 3, and 5. So what we need to do here is find the probability of rolling a 3 or, so that's the important word, or a red number on the die. So what is the probability of rolling a 3 or a red number? So OR goes with the addition rule. And to use the addition rule, we first need to determine if the two events, rolling a 3 or getting a red number, either if the two events are overlapping or non-overlapping. So in order to figure that out, the question we need to ask ourselves is, can the two events happen together? So can you roll a 3 and a red number? So let's check. What are the red numbers? 2, 4, and 6. We don't see a 3 there. So we cannot roll a 3 and a red number together. So these two events, 3 and red number, are non-overlapping events. So they're disjoint or non-overlapping events. So the rule that goes with the non-overlapping events is probability of 3 or a red equals probability of 3 plus the probability of a red. It's simple addition of the two probabilities since there is no overlap. So probability of rolling a 3, it's 1 out of the 6 numbers on the die, and rolling a red number would be any one of the 3 red numbers, so it's 3 out of 6. So when we add the two numbers, we get 2/3. Now, the next question, what is the probability of randomly meeting either a man or, again it's an or statement, an American in a group composed of 20 English women, 15 English men, and 10 American women and 5 American men? So I've written down what is given to us in this corner here. There are 20 English women, 15 English men, 10 American women, 5 American men, 15 English men, and 5 American men. So we can look at it, the information given in many different ways. So let's see what we need to figure out. What is the probability that we randomly meet a person in this group and the person is either a man or an American? So let's first check, since OR suggests the addition rule, let's first check if being a man and being an American are overlapping events. Can the two happen together? What happens if the two happen together? A person is a man and an American. So that is the same as saying the person is an American man. So the two events can happen together. So they are overlapping events. So for overlapping events, we need to use the addition rule. P of M or A is equal to P of M plus P of A minus P of M and A. So what is the probability of being a man in this group? So the probability of being a man is, what is the total number of people that we have in the group? We have 50 people in the group. The English men, women, the American men, women, all together form a group of 35 plus 15, which is equal to 50. So there are 50 people in the group. What's the probability that it's a man? We need to determine how many men are in the group. So there are 15 English men and 5 American men. So the total number of men is 20. So the probability of picking a man from this group is 20 out of 50 plus, so it's an addition rule, so we have a plus. What is the probability of picking an American? How many Americans do we have in this group? We have 15 Americans in the group. So in the group of 50. So the probability of uh, randomly selecting an American person is 15 out of 50. Now we've added the two probabilities, but since there is an overlap, we need to subtract the probability of the overlap. So that would be probability of a person being a man and an American. So that is the same as saying, what is the probability that it's an American man? And let's see what the probability is. American man. So we have 5 American men, and to select randomly an American man from a group of 50 is 5 out of 50. So we just simply plug in numbers into the rule. Once we know what rule to apply, it's just easy because we just plug in the numbers. But the important thing is knowing which rule to apply. So for OR, it would be the addition rule. And within the addition rule, you need to check if the two events that you're kind of adding are overlapping or non-overlapping. For each case, there is a different rule. Another important rule that we've discussed before is the at least once rule. So let's see what the at least once rule is. So the question says, what is the probability of getting at least 1 in 8 rolls? At least 1 in 8 rolls. So we're going to roll the die 8 times, and we're trying to figure out the probability that there is at least 1 in 8 rolls. So that is equal to 1 minus the probability of the opposite event. The minute you see the word at least, use the at least rule. So that would be 1 minus the probability of the opposite event. So the opposite of the event, at least 1 is there in 8 rolls, is there are no ones in 8 rolls. So we roll the die 8 times and none of the 8 rolls gives us a 1. So that is the opposite event. So the reason why we need to take the opposite event is because that is much, much easier to calculate. It is not as complicated as saying at least 1, because at least 1 has many, many cases. So out of the 8 rolls, at least 1 of the 8 rolls is an 8. So you could have something like 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 rolls. At least 1 would mean exactly 1. Now the 1 could be in this spot, the 1 could be in this spot or this spot. There are many, many, many such possibilities. At least 1 would mean 1 or more. So we could even have a situation like 2, 1, 1, 3, 1, 4, 6, 2. So how many ones do we have here? It satisfies the condition of at least 1. At least 1 would mean 1 or more. So if you list all the events, there are multiple events. It's just easier to use 1 minus the probability of the opposite event, and you're going to see how easy it is to calculate the opposite of this event. So what is the opposite of this event? None of the 8 rolls shows a 1. So 1 minus probability that the first is not a 1, and the second is not a 1, and the third is not a 1, and the list goes on, and the last roll does not give us a 1. So that is exactly what happens when we say none of the 8 rolls are 1. So the AND rule goes with multiplication, and since these events are independent, we simply multiply the probability of those events. So 1 minus probability of not 1 times probability of not 1 times probability of not 1. So each time it is multiplication. What is the probability of not getting a 1. Probability of getting a 1 is 1/6. Probability of not getting a 1 is 5/6. So we have 5/6 times 5/6 times 5/6, and it goes on 8 times and then 5/6. So each number is multiplied. It's repetitive multiplication of the same number, and this is the same as 5/6 to the 8th power. So 1 minus 5/6 to the 8th power is 0.7674 that we get using our calculator. Here is another example of the at least one rule. What is the probability of drawing at least one king in 20 draws? So the minute you say at least one king in 20 draws, it could be one king in the first draw, and many other things could happen after that, and maybe no other king shows up, and it's a long list. It could be something like, for example, king, queen, 1, 2, 3, king again, and dot dot dot, 20 other possibilities. It's very difficult. It's a long process to be able to list all this, and it just take forever. So it's just easier to use the one minus rule, so the at least once rule. So probability of at least one king in 20 draws is 1 minus the opposite of that event. Getting at least one king in 20 draws, what's the opposite of that event? Getting no kings in the 20 draws. No king in the first draw, no king in the second draw, and no king in the third draw, and no king in the last draw, which is the 20th draw. The important word here, let's not miss that, is and. No king in each one of those 20 draws. So that's 1 minus probability of no king in the first, no king in the second, times no king in the third, times no king in the 20th. So that is 48/52, which is the probability of not getting a king to the 20th power, and that is equal to 0.7983. And the next one is very similar. Once you get the idea, the important thing is to be able to figure out the probability of the event with the word at least in it, and then using the rule, at least rule, where you go 1 minus probability of the opposite event. So in the next question, we need to figure out the probability that there's at least one L in 8 people, one left-handed person in 8 people. That is equal to 1 minus probability of the opposite event, which is opposite of at least 1 in 8 is left-handed. So opposite of that event is none of the 8 people that we meet are left-handed. So that is equal to 1 minus probability of the first person not being left-handed, the important word is and, the second not being left-handed, and the third not being left-handed, and so on, the 8th person not being left-handed. So if the probability that a person being left-handed is 0.11, then the probability that the person not being left-handed is 0.89. So we plug in the numbers, use our calculator, and get the answer. So when we read a question in probability, the important thing is to look at the event for which we're trying to figure out the probability. Write down the probabilities that are given to us. What is given to us is the probability that someone is left-handed. What's the other conclusion that we can make from this probability? What is the probability that someone is not left-handed? How do we get that? We go 1 minus 0.11. So first write down your probabilities in notation. Don't write it in words, in long sentences. Write it in notation, in mathematical notation. Then write down the probability that you're going to figure out, that you need to figure out, and then write down the formula that you need to use. I want you to read this question carefully. You can pause the video. The first thing we need to do is make a note of all the probabilities that are given to us. So the probability of a $2 winner is 1 in 10, a $5 winner, 1 in 50, and the probability of a $10 winner is 1 in 500. So write down these probabilities in mathematical notation first. P of $2 is 1/10, P of $5, 1/50th, P of $10, 1 over 500. So now we have a list of all the probabilities that we can use as soon as we know which formula to apply for the probability of the event that we need to figure out. Let's write down exactly what probability we're trying to figure out. What is the probability of getting either a $2, $5, or a $10 winner? So we buy a ticket, and this is the probability that we're trying to figure out. What's the probability? We write it in symbols. We get a $2 or a $5 or a $10. So the important word here is or. Or goes with the addition rule. But before we use the addition rule, there are two possibilities. One is for overlapping events and the other is for non-overlapping events. So think about winning $2, winning $5, winning $10. When you buy a lottery ticket, you cannot win all three together. You either win $2, you either win $5, or you win $10. You cannot win all three or even two at a time on the same ticket. So they are non-overlapping events. So that's the important thing, non-overlapping. So that tells us that we need to use this addition rule where we simply add all the probabilities. Probability of winning a $2 or a $5 or a $10 is probability of $2 plus the probability of $5 plus the probability of $10. So that adds up to 0.122. So probability of $2, when we figure it out, is 0.1, and the probability of winning any one of these, where we use the word or, any one of these prizes is 0.122. So the probability of winning one of these three amounts is greater than winning just the $2 amount. So your probability of winning that would be greater. So the next question says, if you buy 50 lottery tickets, what is the probability that you will get at least one $5 winner? The minute you see the word at least one, it's a complicated situation. At least one would mean either one or two or three or four or five. So there are many, many possibilities. So if you see the word at least in the event for which you're trying to figure out the probability, use the at least rule, which says probability of at least one $5 winner in 50 tickets is equal to 1 minus probability of the opposite event, which means none of the 50 tickets is a $5 winner. So that is equal to 1 minus. The first one is not a $5 winner. The second one is not a $5 winner. And we keep going. The 50th one is not a $5 winner. So probability of winning $5 is 1 over 50. Probability of not winning $5 is 49 over 50. We plug in the number and get an answer. So the probability of getting at least one $5 winner if you buy 50 tickets is pretty good. It's about 63.58%. Now, what if you buy 500 lottery tickets? What is the probability that you will get at least one $10 winner? So what is the probability of getting a $10 winner? It is 1 over 500. What is the probability of not getting a $10 winner? It is 499 over 500. How did we get this? We went 1 minus 1 over 500. If we take the LCM as 500, then we multiply the numerator and denominator by 500. So we get 499 because it's 500 minus 1, 499 over 500, or just use your calculator. So what is the probability of getting at least 1 in 500, winning $10 in at least one of the 500 tickets that you buy? So 1 minus the probability of the opposite event. That is the rule. What is the opposite event of at least one is a winner? None of them are $10 winners. The first one is not, and the second one is not, and the third one is not, and the 50th ticket is not a winner. So it is 1 minus the probability of not winning $10 in the first ticket times probability of not winning $10 in the second ticket times probability of not winning $10 in the last ticket. So that is equal to 1 minus 499 over 500 to the 500th power. So that is 63.25 when you plug in the numbers into your calculator.